Assalamualaikum and a very good morning everyone. Thank you for coming. For discussion today is related to biochemistry and bodily functions related to the digestive system. Before that, let me first introduce myself as the chairperson. My name is Nur Alisa Shamira and my matrix number is 190274. So our discussion today is related to the question what will happen if a cow ate sawdust. So imagine a situation where a sawdust factory is located next to a cow farm and the sawdust travels to the cow farm and the cow eats them. So before starting the discussion, let us first introduce ourselves starting from the furthest right.
Hi everyone, my name is Shazwani binti Lokman. My matrix number 19.0.19.7.
Hello everyone, my name is Noor Nadira binti Abdul Hamid and my matrix number is 186861.
My name is Tan Wei Yang and my matric number is 188722.
Hello everyone, my name is Charlene binti Ahmad Sharizal Azwa, matrix number 189824.
Hi, good evening. My name is No Akila binti Ahmad Anwar and my matric number is 187312.
Hello, my name is Nurul Akila binti Muhammad Soeb and my matric number is 190507.
My name is Haful Farana Medicine Abidin and my matrix number is 190181.
Hello everyone, my name is Tan Iwan, matrix number 189724.
Hi, my name is Nur Atifa binti Muhammad Apandi and my matric number is 189744.
Okay, thank you everyone for introducing yourselves. And so to start off this discussion, who would like to start the discussion?
So I will be talking about the learning objective for this discussion. First is to identify the composition of sawdust used to feed the cattle. Next is to discuss on the effect of sawdust feeding on cattle. Next is to identify the sign of impaction after sawdust feeding. Fourth is to understand the biochemical digestion process of ruminant. And lastly is to classify the precaution needed in feeding sawdust to cattle.
So next I will be talking about the definition of sawdust. So basically sawdust or wood dust is a byproduct of cutting, grinding, drilling or sanding wood or any other material with a saw or other tool. It is composed of fine particles of wood. It is also the byproduct of certain animals such as birds and insects which live in the wood, such as the woodpecker and the carpenter ant. Basically, daily farmers who are critically short of cash and normal forage, straw or stover might consider feeding of hardwood sawdust in limited amounts for their cattle. The normal amount or the basic amount of sawdust that can be fed to the animal, for example, for large breed dairy cows, it might be fed to 6 lb of sawdust daily in a low forage high concentrate ratio, while for dry cows or heifers probably should be limited to 1 to 2 lb daily as a substitute for part of the forage that is fed. Out of 200 years ago, it was found that the large molecule carbohydrates in wood, namely cellulose and hemicellulose, can be fractionized by acid treatment into simple sugar such as glucose, hexose, and pentose, and thus converted to food. Because of the huge investments necessary to build production facilities, this has only made sense economically in times of need. But as ruminants, for example the cattle, are able to utilize cellulose through enzymatic solubilization, studies has been carried out to establish whether the wood products could be used in addition to grass and other fruits. Experiments which fermented or acidified wood flour has been successful. For example, in India, a suitable solid-state fermentation process has been developed to enhance the biological composition and nutrition value of sawdust. These experiments state that cellulose made from sawdust can possibly be used as feed if it is carefully derived and finely ground. Therefore, the farmers should know the exactly amount of sawdust needed to feed their cattle in order to maintain the health of the cattle and also avoid overfeed of sawdust that can be that to and avoid the overfeed of sawdust to avoid any complication that can occur to the cattle.
So for the digestion of energy feeds in the rumen of cow, so it consists of the simple and complex carbohydrates are digested by rumen microbes, and converted into volatile fatty acids. The volatile fatty acids, which consist mainly of acetic and propionic and butyric acids, are the primary energy source for ruminants. When the large amounts of forage are fed, the formation of acetic acid predominates 60 to 70% of total, with lesser amounts of propionic 15 to 20% and butyric 5 to 15% acid occurring. However, when grain feeding is increased or when finely ground forage are fed, the proportion of acetic acid may decrease to 40%, while the amount of propionic acid may increase to 40%. Such a change in volatile acid production generally is associated with the reductions in milk fat tests. Approximately 30 to 50% of the cellulose and hemicellulose is digested in the rumen by the microbial populations. 60% of more of the starch is degraded depending on the amount fed and how fast ingested material moves through the rumen. Most sugar are 100% digested within the rumen. The volatile fatty acids are absorbed from the rumen into the bloodstream and transported to the body tissues, including the udder, where they are used as a source of energy for maintenance, growth, reproduction, and milk productions. The cow derives 50 to 30% of its energy from the volatile fatty acids produced in the rumen. So that is all my part. Thank you.
I would like to touch about the nutritional value of sawdust. Since we want to talk about the effect of the sawdust towards at limiting feeding to the cattle, so I think we need to know what the types of the dietary nutrients of the sawdust. So based on my readings, the sawdust is a dietary fiber, or also known as roughage, that is indigestible, mostly in animal, but in cattle. So in this case, cattle, or known as ruminants, which have 4 chambers of stomach, can turn this indigestible material into energy through the fermentation in rumen. So they can utilize these indigestible materials for their nutritional needs in body. So this fiber will be fermented by the rumen bacteria, or also known cellulitic bacteria that is present in the rumen. So the bacteria species can be the examples which are Ruminococcus flavifaciens, or Bacteroides succinogens, and also Butyvibrio fibri solvens. So these are the examples of cellulitic bacteria that will turn this cellular structure of the fiber into the volatile fatty acids. And these bacteria will break down the cellulose into these volatile fatty acids, which will be absorbed by the animals in the digestive tract. So the fermentation product basically is volatile fatty acid, butyric acid, and also methane gas. And through this proliferation of these bacteria through the fermentation, the continuous supply of the fiber actually give these bacteria to multiply or proliferate into a larger community or quantity, so that they can digest this fiber that is supplied continuously, which is ad libitum feeding from the cattle. So this will increase decrease the digestibility of the digestion. And the protozoa, actually in rumen, there is various types of microbes that are present, which are bacteria, fungi, protozoa, and all these microflora will actually work together to maintain this good condition or environment for the bacterial fermentation. So the protozoa in rumen actually will stabilize the number of bacteria from the proliferation, which they will actually eat these bacteria, so that it can control the environment, the pH of the rumen, for the optimum fermentation to occur.
I will be continuing the discussion. So cow guts are packed with microscopic organisms, which are a diverse group of microbes that live within the digestive systems of ruminants. So bacteria, fungi, and single-cell animals are called protozoa. So microbes allow animals to break down complex materials such as amino acids, cellulose, starch, and sugars into simpler products that can then be broken down by the animal's own metabolism. So proportions of microbes present vary greatly depending upon the diet of ruminant. So all animals carry a huge load of bacteria, but microbes that live in one special gut compartment in cows are special because they digest cellulose. So one particularly important bacterial genus that takes part in the degradation of cellulose is gram-positive ruminococcus that converts cellulose to glucose, and it's important because it is rare for organisms to be able to break down the beta-1,4 linkages. Glucose is then further converted to acetate, pyruvate, or lactate through glycolysis and fermentation. So in the process, NAD+ is oxidated to NADH, producing hydrogen gas that is used with the carbon dioxide to release the CH4 into the environment. So ruminant does not secrete any acids or digestive system enzymes in the rumen. Rather, all digestion in rumen is done by rumen microbes. So this symbiotic relationship enables ruminant to digest this fiber without having to encode for more enzymes in their own genomes to do this job. So when the rumen bacteria of a sample stomach contents is killed using antiseptic and then mixed with fluid with cellulose was digested. But when rumen fluids and cellulose were mixed together without an antiseptic, various gases and acids were produced that showed that cellulose can be broken down. And this was followed by research looking at what was actually produced during rumen fermentation. It turned out that this one product, short chain fatty acids, provided a large proportion of a cow's energy needs.
Now I will talk about the advantages of sawdust. Sawdust is probably the most commonly used bedding products for dairy cows. The smaller particle size of sawdust makes it more absorbent than wood shavings and quicker to break down. They have the advantage over sand of being broken down by microorganisms in the disposal system. The first advantage of sawdust is sawdust serves as a mulch. It helps to improve aerations and structure of heavy soils. If you have vegetable or fruit garden, then it is extremely important that the soil is fertile and plantation worthy. Sawdust mulching will increase the airing and also the structure of the heavy soil to increase the yielding, and you can enjoy organic vegetables at home. Second, mulch help to improve mouth help to increase penetration and water absorption. If your garden is not yielding anything properly and plants are dying, then you might give your garden a break and treat with sawdust to get the soil more fertile and start planting from next season. Last but not least, it also helps in weed control and decrease evaporation to control moisture. When there is a lot of weeds around the plants, then the moisture and nutrients from the soil has to be shed and your plants don't get it enough. Also in summer, due to high rate of evaporation, the moisture in soil quickly blows away. Spreading sawdust mulch is a solution to both these things, as sawdust will help counter weeds and also help to actively work as a layer protecting the sun to evaporate moisture from the soil.
Overfeeding cattle with sawdust can result in certain implications. One of the disadvantages to overfeeding cattle with sawdust is impaction. Impaction is the blocking of the digestive tract. It prevents animals from defecating and eventually it kills them. So to spot the signs of impaction in cattle, we can observe them kicking at their belly. This implies that the cattle has indigestion. They will also have lack of normal rumen sound. Also staggering since the cattle is weak, complete anorexia, scant feces, and ill thrift, which is the insufficient weight gain or inappropriate weight loss. So because of that, it is crucial to feed cattle with the proper amount of sawdust. There are also several precautions that farmers need to take in feeding sawdust. Farmers should not use any material that contains walnut, since walnut increase the incidence of founder. This implies not only to cattle but to horses too. Softwood sawdust is too poorly utilized to warrant feeding. High levels of wood residue intake, or when it is fed for long periods of time for over 90 to 100 days, will cause splinters in the GI tract or impaction. Therefore, it is encouraged to put sawdust through a screen to remove slivers first. That is all.
So I will talk about the effect on cattle. As what Dira has said before, that overfeeding sawdust on cattle may result in implication on their health, and this is because the softwood is too poorly utilized to warrant feeding, and some problems with splinters in the GI tract or infection may actually occur at higher levels of wood residue intake, and when it is fed for a long periods of over 90 to 100, it is because the size of fiber particles in the diets of grazing cattle is very important in maintaining their optimal rumen function.
I think I can explain a bit more about rumen fermentation, Kila. Basically, we all know that the rumen is the first compartment of a ruminant's stomach out of all four compartments. So, basically, when the cow eats the sawdust, the food will enter the rumen first. It will mix after being mixed with saliva in the mouth. And once the sawdust enters the rumen, it will be mechanically broken down to smaller pieces and then passed on to the reticulum, like Safa has mentioned earlier. So when this food is broken down, specific bacteria is found in the rumen, such as Ruminococcus flavifaciens, Ruminococcus albus, and Streptococcus bovis, which are amongst the kinds of microbacteria you can find in the rumen, will actually break down the cellulose in the sawdust, which is, by the way, 90% of the composition, as a large composition of the sawdust, as mentioned by Wei Yang. So, once the sawdust has been broken down, it will separate into separated and formed into cuts, which will then clump and then regurgitated into the animal's mouth, where it's re-chewed and then re-swallowed back into the rumen, also as explained by Safa earlier. So these microbes that I've mentioned earlier will actually help in the fermentation process. Apart from that, I would also like to include a few difficult words that I have found while doing this research before this discussion continues, so we may further understand some of these things that our friends have been talking about. So, the first word is dry matter. For all of you to know, dry matter is actually the part of a foodstuff or other substance that would remain if all of its water content was removed. Next is crude fiber. Crude fiber is a measure of the quantity of indigestible cellulose, pentogens, lignin, and other compositions of this type in present foods. So, as we all know, sawdust has a lot of crude fiber. Next is ruminococci, which is the kind of bacteria from the class Clostridia. I've mentioned two types earlier, which was Ruminococcus flavofacins and Ruminococcus albus. So they are anaerobic and they are gram-positive gut microbes, which can be found in the intestines of humans and also in the rumen of ruminants. Next is efficacious, which is actually typically of something inanimate or abstract, which is successful in producing a desired or intended result. Next is exogenous enzyme, which is actually just enzyme that originates from the outside of the organism, or in our case, the ruminant. And lastly is Artiodactyla, which is the even-toed ungulates, meaning finger or toe. They are basically hooved animals whose weight is borne equally by the third and fourth toes. For in this case, our Artiodactyla are ruminants. Okay, and that is all from my side. Thank you.
And I'll continue my part. The natural digestive fiber in the sawdust may actually reduce the rate of fermentation and reduce feed intake, but if too little also may lead to rapid rumen fermentation and potential acidosis. The diets of the animal greatly impact their own health and also affect the consumer because of their meat, and will also affect the environment. Sawdust and wood shavings are probably the most commonly used bedding products for dairy cows. They have the advantage over sand of being broken down by microorganisms in the disposal system, and also disadvantage because allowing growth of microorganisms like pathogens. And the smaller the size of sawdust actually makes it more absorbent than wood shavings and quicker to break down. However, small particle size is associated with rapid growth of bacteria and other harmful pathogens, and the cost and availability tend to be deciding factor in choice of material.
Thank you. Now I'll be explaining about the rules of using sawdust as roughage. In severe drought, sawdust may be used as a cattle feed, especially when roughage becomes scarce, expensive, or both. But sawdust must always be considered as a last choice of roughage, because sawdust basically has no nutritive value at all. Its function is a mechanical one to allow the rumen to work, while sawdust can be a roughage substitute when high grains diet are fed. The rules for its use are: use coarse sawdust in preference or to fine sawdust. Do not use sawdust at more than 15% by weight of any diet. For example, 6 kg of grains should be mixed with no more than 1 kg of sawdust. Confirm that the sawdust has not been derived from timber treated with pesticide, nor contaminated with pesticide or other chemicals during storage or transport. Sawdust and shavings have been identified as a source of organochlorine contamination. Organochlorine has been used around sawmills in the past to control white ants. Do not use sawdust from treated timbers. They could contain copper, cadmium, or arsenic, which is harmful to livestock. Do not feed to cows less than 20 weeks old, and always watch for evidence of impaction. Impaction is a blocking of digestive tract, preventing animals from defecating and eventually killing them. Where sawdust is used at rates up to 15% by weight of the ration, impaction should not be a problem. At higher rates of use, impaction in the rumen and omasum is more likely to occur, especially after prolonged feeding. If sawdust is fed with a molasses-based ration, impaction should not be a problem. Signs of impaction, which will be explained by Nadira later.
Alright, so to conclude the discussion for today, for what we have gathered, I we think that eating more sodas or too much sodas can bring more harm than good to the cow, since the sodas component have some of the materials are hard to be digested and cannot be digested at all by the cow metabolism and the cow digestive system. So if digested too much, in particular in this situation, it can bring more harm than good and even cause diseases to the cow and even sicknesses, and to a certain point it can even cause death to the cow if no action is taken to prevent the cows from eating too much sodas. So yeah, thank you everyone for the discussion today. I think this was a very fruitful discussion as we got to know more about the situation. So thank you everyone for participating, and I hope everyone has a good day ahead. So yeah, thank you everyone.